Ready? Paras to paras. Right? That's never good.
Right, guys, so we're picking up where we left off. We looked at the electron configuration last, but we were there was more background knowledge, right? But what we were essentially looking at was the different types of bonds. And we're discussing electrovalency, which is an ionic bond, which is between a metal and a non-metal. And we looked at how, in the case of lithium and chlorine, how the electron got transferred over, right? I want you to turn to on page 7. Right, this is a model showing a structure for sodium chloride, NaCl. Right, the small spheres represent the Na plus ions, and the larger spheres represent the chlorine ion. What you need to note that this is an electrovalent bond or an ionic bond. The positive particles are the sodium, and the negative particles are the iron, right? So we're looking at NaCl, right? So this is your positive.
It is a 3 minutes, 34 minutes. 34 minutes. Ready? Ready? Exactly.
Right, so in terms of the salt, the sodium chloride compound, we've got a positive and a negative ion. So when we have a positive and negative coming together, this is an example of an electrovalent or an ionic bond, right? And then they got some theory at the bottom there, right? At the bottom of page 7. An electrovalent bond is formed by the transfer. I want you to check your highlights and just highlight that line, the transfer. You must get stuck in your head, right? I'm sure some of you would remember it from the trick. Right? An electrovalent bond is formed by the transfer of one or more electrons from one atom to another, right? So that the ions formed have the electronic configurations of one of the noble gases, right? In terms of Lewis's theory, right? Lewis recognized that in simple molecules, another form of bonding had to operate, and he suggested that electrons might be shared. Right, so we're looking at the next type of bonding, which is covalent bonding. So this was all about ionic or electrovalent bonding. The next one we're going to be looking at is covalent bonding. Right, the definition of this here is a sharing of electrons. Right, so covalent bonding is the sharing of electrons, right? So, if we go back to the notes here, they say, thus consider the chlorine atom which has 7 electrons on its outer shell. If 1 electron is provided by each atom and shared equally, then such a chlorine atom can acquire a share in 8 electrons and complete the octet, right, as it's sometimes called. Want me to turn over? So the example there, now we're actually getting into the Lewis dot structures, right? The dots represent, so if we look at this here, we're taking 2 chlorine molecules, right? We've got a chlorine plus another chlorine will yield what? Right? So in terms of drawing it in Lewis dot structure, we're gonna draw a chlorine there, and then if you go to the periodic table, you'll see the number of electrons for chlorine is 7. Right? So what you do is you start like this here. You go 1, 2, 3, 4, 5, 6, 7. Right? Now then the other one will obviously mimic this here. So let's mimic, let's do the other one. So it's going to be 1 on the top, 2, 3, 4, 9, 5, 6, 7. So what can we see here? This electron here and this electron are called lone pair. And these are your lone pairs. Right? What happens is when we put these 2 electrons together, they then share a bond. So basically, if you put these together, 2 together, I'm going to donate this one here with the dot and this one with the X. Right? So put the dots around here. Right? And this one has your X's. And you see there's a bond being created, and this bond is right. But why is the bond being created? Because of something called the octet rule. So if we look around this chlorine here, we got 2, 4, 6, 8, right? And it completes 1 octet here. Then around this chlorine here, we got 2, around this chlorine here, we got 2, 4, 6, 8, and it completes another octet. So the bond created was a sharing of electrons, and it satisfies the octet rule. Right? The octet rule basically states that when electrons don't have, when elements don't have 8 electrons around them, they are reactive. Right? When they have 8 electrons around them, they are regarded as stable, and in other words, they are not reactive, and therefore they can't create bonds with any other element. And you get what I'm saying? It's a stable compound. Right? Which group in the periodic table will have stable elements?
Center.
No, which one has 8 electrons? Group?
Last group where helium and
Yeah, group 8. It's your noble gases. It's your noble gases, right? Group 8, your noble gases. Right, so that will be the one that will have your stable or your most stable elements.
So does that mean that they won't react with other?
They can act in other reactions, but usually they don't react. Yeah. Alright, your notes, you can take down these notes, right? Let me just go to the periodic table so you'll get familiar with this here and you'll know how to actually do the Lewis structure.
Now, or helium, Leo, carbon.
So you haven't got a separate group for chemistry?
Yeah, I'll start one for,
Do you want to start one?
I don't know,
Yes.
I think we should. Because, I think we should. Okay.
You'll have Wi-Fi for students.
We got Wi-Fi, yeah.
You get your money's worth.
Yeah.
Huh?
No, but I'll this thing, I'll find out. Maybe we can create one just for the you guys.
No, last
So let's say guys are you done with the board. Alright, let's move on to this video, right? Not video, I mean this periodic table. Now, if we look at the periodic table, right, we've got group 1, right? Group 1 following here, right? Group 2, group 3, group 4, group 5, group 6, group 7, group 8. Right? Everyone's with me?
Yeah.
Right now, to work out the number of electrons per group, group 1, this we got hydrogen on top there, right? The number of electrons for hydrogen is 1. So it's equal to the group number. The number of electrons is 1 for group 1. For group 2, the number of electrons is 2. For group 3, the number of electrons is 3. Right? Then we come to group 4. Right? From group 4 onwards, it's 8 minus the group number. From group 4 onwards, it's 8 minus the group number. So for carbon, it's in what? Group 4. So how many electrons?
4.
Right? Nitrogen?
3.
Yeah. And oxygen?
2.
Right? Fluorine?
1.
And the last one?
0.
0.
Oh, 0.
8 minus 8. Alright, so that's the rule. Should I write that down for you guys?
Yes, yes.
This is the number of free electrons.
Valence electrons, yeah.
So this is electrons that are available for
bonding.
bonding.
Yeah.
So,
Right.
So what's that section in the
Transition
center?
metals.
Yeah.
It's called transition metals. So those transition metals can, it's like diatomic, it can occur in one of three forms. So that's why we leave it out. Right?
Yeah, I'll use for this week.
So do they do take part in reactions though?
They take part in reactions, yes. Nice handwriting, good. It's very neat.
Oh. So this is the one I went to but I asked for there was a large. So this call. So Chan.
Alright guys, is that? Almost.
So what we're realizing is that we go home from here, we got a lot of stuff to do
Six.
before we come tomorrow.
Tomorrow.
It's
Oh, you're doing your homework for every subject?
yeah.
Yeah.
Like, don't make yourself smile.
You have to make your time, man. You know how it works is that for every hour of delivery, you must do 2 hours of homework. That's how it works. For every hour of delivery, for you to actually get the knowledge from the module.
Yeah, so this back-to-back days is not gonna work.
No.
You're just not gonna have enough time.
Why? What you doing on other days?
No, but we need to finish that.
All the work we got needs to be done tomorrow.
Yeah. So it's this thing. It like even if you do it Monday to Thursday, you're still gonna get work.
What he's saying is like maybe on Monday.
What will happen is
Give him a
you'll even finish the program. If you're doing Monday to Thursday, you're still gonna get the same amount of
No,
work.
Abdi, I think what he's saying is,
What?
we got it back to back, so we got it on Thursday and Friday.
Right.
So we do the lectures all on Thursday.
Yeah.
Every single one, the guys want to go home and catch up and stuff. But we only got so much stuff for the next day. it's like, so they say maybe a Monday and a Thursday. I don't know, that's what you're trying to say, Trevor. Right?
Monday to Friday.
Again, homework on Friday.
So there's time in between while we wait for the next one.
I get what you're saying,
Yeah, okay.
but but in normal circumstances, it doesn't work that way. That's days on your personal capacity, you can't cope with that, right? But on a normal circumstance, if you're going to campus, you on a Monday to Friday, you're going to DUT or anyway, they're going to give you work every single day that you need to come in the next day. There's no period in between. So I know what you're saying. It's a lot of work and stuff, but
Sometimes you just gotta look at all the difficult subjects, like all heavy subjects, the easy subjects, you don't do.
honestly, yeah, to be honest, you guys should focus more on maths and science because the chemistry you can catch up. This whole the chem plan whole textbook. If you really push it, you can learn the whole textbook in one weekend. Honestly, yeah. You can go over the whole, like for the exams, if you learn like 48 hours before the exam, for my exam, you'll pass. I'm not even joking. You go over the past year papers and stuff, you're gonna do it. No, but I'm just trying to say, like, comparing it to where you got an application subject like maths and science, where you have to constantly be working to get the concepts, where this here is more of a theory. This, all the things I'm teaching you is just theory. All this is theory.
So from all
It's
our
like basic
subjects-
understanding. There's like no calculation here. There's nothing hard to understand.
So I think maybe just come back to Trevor's stuff. From
Yeah.
all our subjects, we've got four subjects.
Four
right?
subjects,
Right.
yeah.
So most priorities you put in maths first, all
Yeah.
examples, then next
Physics.
then chemistry, and then the last is
Chem plan.
So maybe that's how you.
Chem plan, we already worked out the calculations. There's no other calculations there. It's only theory day after. So chem plan should be like, hey, even if I didn't teach you anything, you'll still pass it on your own. You know what I'm saying? Yeah. All right.
Don't say that now because we can realize.
No, not that you skip. No, but if you're here today, like how she said that she wants to leave early. But if you're here today, remember you still have to come into the class and all. Don't like come and you'll only come for math and science. It doesn't work that way. Yeah, you still have
No,
to
I
come.
know, I'm
Yeah.
just saying like he replayed. So
Yeah.
But just don't say that we'll all pass because people at SAPF will miss you.
No. You guys, everyone, I'm confident that everyone will pass.
Engine is still running.
Alright, guys, let's go back. So we looked at on how we draw these electrons around this here, right? So for chlorine, it's in group 7. So what it tells us is that how many free electrons does chlorine have? How many valence electrons? So in terms of that there, how many bonds can it form in terms of covalent bonding? Just one. So the number of valence electrons will tell you the number of bonds that can be formed. Right, now let's look at the next example here with oxygen. Oxygen atom has 6 electrons in its outer shell. Right, an oxygen molecule, O2, a stable electronic configuration can be assumed to be attained by sharing 4 electrons, 2 being provided from each atom. So let's go to oxygen. Let's look at the periodic table once again. Right, can you all see here? Oxygen is in group 6. Now, according to our rules, what does it state? Right, it's 2. Right, so we know that we get 2. Yeah. So if we are, but it's in group 6, so how many electrons in total are we going to have around it? So we're not looking at, this is what we're looking for, valence electrons. How many total electrons around oxygen? 6. Right? So I'm not going to draw it on the board, it's just taking your time there, right? So you can see there that oxygen and non-oxygen, you got 2, 4, 6. Right? The next oxygen is got 2, 4, 6. Right? But to satisfy the octet rule, how many do we need around each one? 8. Right? So we take 2 from one oxygen and another 2 from the other oxygen, and we create 2 bonds. Can you see that? The bonds are denoted by dashed lines. So when we create a bond here, let's say for example we had this chlorine, once it's formed, we don't have to draw the Lewis dot structure around it. We can just draw a short notation showing the bond. So this is equivalent to that. Right? The dash line is basically showing this bond. So you don't have to draw it out there like that, and you don't have to draw it around. Just show the dash line. A single bond created between two chlorines. Now let's look at the oxygen quickly. We've got, I just want to show you all the alternate rule things so you'll get used to it. You got 2, 4, 6 oxygen, 2, 4, 6. Then we said that it has 2 valence electrons from one and another 2 valence electrons from the other one. So if we put these 2 valence electrons here, we show this with the X, that X. We've got 2 here, 2 here, 2 here. Yep. XX, and we can see that these two form a bond, these two form a bond. Then we're just drawing the notation without the Lewis dot structure, similarly, a double bond. One bond here, another bond here. Everyone understands? Right, so, and then in terms of the octet rule, right, we got 2, 4, 6, 8. So this oxygen satisfies the octet rule. And if you look at the other oxygen, it's also satisfying the octet rule. You got 2, 4, 6, 8. Right, so it satisfies the octet rule. Now, similarly, we look at nitrogen. Now, nitrogen, if you look at nitrogen, what group is in nitrogen? 5. Right, according to this here, 8 minus 5? 3. So how many bonds you gonna get between two nitrogen? 3 and 3. Yeah, 3 bonds. Same thing there. You can see they drew the dot structure and they showed you the 3 bonds. If you take your pen and go around it, you'll see that it satisfies the octet rule. You'll have 8 electrons around each nitrogen. Right? Then we're looking at something. So we're looking at bonds between the same element. Now let's look at a bond between 2 different elements. Like HCl, what's HCl? Hydrochloric acid, right? Now let's look at a bond between a hydrogen and chlorine. The molecule is said to possess an electrical dipole, right? And this is responsible for a substance having a boiling point higher than it would otherwise have had, right? So to indicate the presence of an electrical dipole in a molecule of the following, annotation is often used. But you can see here, so just like, you know, you get the North Pole and the South Pole, right, in the world. We're looking at this bad example, but anyway, in terms of chemistry here, we have 2 poles, a positive pole and a negative pole, right? So the substances that lie more on the left, if you look here, hydrogen is on the left here, right? Where's chlorine? Halogen, sorry.
Hydrogen is 7.
Yeah, it's in group 7. So chlorine is on the far right, hydrogen is on the far left, right? So how it works is the one that is more on the right hand side will be the negative pole, right? And the one on the far left will be the positive pole. So if we go back to the example here, right? We got hydrogen. Remember, hydrogen is in group 1. So how many valence electrons? 1. So we know chlorine is in group 7. 8 minus 7? 1. So we know that we have 1 bond being formed, right? But according to the number of electrons around hydrogen, it's in group 1. So number of electrons will be 1. Chlorine, group 7, 7 electrons. You draw your electrons around it, you show the bond being formed, right? Yeah.
How come hydrogen always H2?
Yeah, because the hydrogen is very reactive. It always, in stable form, it's in H2. So it usually doesn't naturally occur as just H. Yeah. It's a very reactive element. right? So yeah, so we got when it's very active, it always needs to combine with something else, and usually it's H2 naturally occurring, right? So we've got your hydrogen and chlorine being formed. Like you all know, you said it's HCl is a acid, right? Hydrochloric acid. Then indicate the presence of an electrodipole in the molecule. So because this here was on two opposite ends of the periodic table, right? So we know on the far left we have one side, and the far right we have another side. The electron affinity, so if we go down here, I think they should have explanation here. Yeah, there's it. Electron negativity. You can see here, it goes from left to right. So something that has a high electron negativity, right? Negativity means more negative. So something on the left hand side would be more positive, and as you move towards the right hand side, it will become more negative. So if you have, for example, if I give you two elements like N and O, right? Which is a positive pole and which is a negative pole? N and O. Yeah. And negative the O.
Yeah, because you said.
Right now, what if I give you O and S?
It's the same thing as positive.
Sorry?
It's both positive.
They're both positive.
But now between the top and the bottom, which
Yeah.
would be.
So what happens when you move down the periodic table? How does electron negativity work?
We go back.
So look at it here. So when you move down the periodic table, so the ones more on top has the higher electronegativity. So the one below will have will be more positive. So we look at S and O again. You all tell me now which is the negative and positive pole. S is going to be the and O is going to be the right. I think I'll print out this periodic table for you, right? And then whenever we write the compound out, we always write the positive first and the negative after. We don't write OS, we write SO. Right? Or like in the case of HCl, we're writing the H first because it's a positive pole. We write the positive pole first and then the negative pole. That's how we form it's like a rule for compounds. Okay? But it's all metric, not really metric.
It's 3 or so.
Yeah, but we're learning, right? So yeah, so that's your positive and negative pole. It's given by this symbol here. It looks like your pole is given by this here. So it's your positive and negative, and you've got this arrow here like that. And then in terms of this side, it's going to be sigma positive here and sigma negative here. And then we're going to say electron negativity and electron negativity. Let's take this down here, folks, right? Alright, since you've got so much of homework, I won't give you a chemistry homework, right? You're right, you happy, Trevor?
Steam is coming out of jail again.
Yeah, we're gonna round up there. We kind of out of time, but don't stress. This we okay for time with chemistry in terms of our. But let's take this down. what I want you guys to do, if you can, I want you to read up until page 15 for me. Homework, okay, that's the homework. Yeah.
So much for not homework.
That's not too bad, I'm reading, come on.
Hey, very good, slow reader.
Huh? No, read it out. Right, I need the registers, guys. Yeah, okay. Okay, thanks, guys. We'll see you all tomorrow.
Thank you.
Cheers. Okay, we're coming in tomorrow. You make it. Don't see how it goes. Okay.
Yeah. Can't be 6 or 8 days.
Yeah.
Thanks, guys.
Right.